This is usually when my internet drops out. Go live. Welsh internet is not the most reliable. So, hello everyone. Thank you for joining. There's no intro today because I forgot to press it. But here's Dave. David Flanagen, also known as Rawkode. Do you want to do a quick intro, Dave?
Yeah, happy to. My name is David. I'm in Glasgow in Scotland. I'm the founder of the Rawkode Academy. It's a YouTube channel to help people with cloud-native Kubernetes, service mesh, microservices, and all of the bits adjacent to that. And my favorite programming language is Rust, and today we're getting rusty, which I'm very excited about.
Getting rusty. I have dabbled with Rust. It was at that point when like Rust or Go, what am I going to use? I went with Go because it seemed easier. So I'm gonna stick with this. It looks easier to use. And it's quite easy to use. I use Go a lot now, but Rust is gaining more and more momentum, right?
Yeah. So the thing is, right, Go is a very simple language, and that's by design. It was designed to be easy to pick up and work with, even though it has some difficult concepts under the hood, such as channels and concurrency. But the syntax is very familiar for C developers because it was built by people that actually created the C programming language, right? Rust is a completely different beast altogether. It's not C-like. It has some C-like things. And then the memory management is obviously very bespoke to Rust. It's the first time this has ever existed in a language, at least of this level of adoption. But Rust is a beast. I've been writing Rust for 6 years now, I think, and I'll tell you, I'm not a master of Rust. I still bang my head off my table every single day. You can learn the syntax, you can get comfortable with Rust, but I do think that it's a lifetime to master, just because there are so many things that you need to get to grips with the language. So, yeah.
And it does so much, right? I mean, it goes all the way from embedded upwards.
Yeah, I mean, originally it's a systems programming language, so people expected it to be built to write like system Ds and operating processy style stuff. However, we're now in a position where Rust is part of the embedded ecosystem. People are building kernels with it. People are building for the kernel with it. We also have WebAssembly. Rust is now in people's browsers, delivering super fast interactive experiences. So it's a language that has transcended its initial scope and is now literally everywhere you go. Even if you're not writing Rust day in, day out, you're using Rust. Sorry? Oh, is your internet gone? No, you're back.
Yeah.
You were just saying that was going to happen.
Every time, like, it goes just, it's fine, and then bang, I'm just going to disappear for 5 minutes.
Well, you're back now.
Like nobody at home.
We're all good.
Right. Should we dive in?
Yeah, let's go for it. Yeah. What do you want to do?
I did a quick Google. Which one was it? Over here. Here we go. No, wrong one. All the way over there. There we go. Right, Rust API framework. If I wanted to build an API in Rust, what would I use? Obviously, the first thing that comes up is like the Rawkode framework. You mentioned one to me. I've tried one. What is like, if I want to build like a fast asynchronous API in Rust, what do I look at? What do I go for?
So there are a couple of options for writing web-based APIs in Rust. Like the first one that's come up there on Google is Rawkode. This was one of the first ones to come out, and it was kind of opinionated right off the get-go. Their mission was to be the Rails of Rust. So really, it's like batteries included. We do everything, get an API in under 10 minutes. Fantastic project. It was kind of controversial for a while because it did require a lot of Rust unstable features. But in fairness, there's a lot of cool stuff in Rust unstable. So that was understandable. So, if you've never written Rust before, you want something off the ground and you want to do a POC, Rawkode is probably a pretty good starting point. There is one other one, which is very similar called Warp, which is also a very interesting project. It will try to get you off the ground. It's not as batteries included as Rawkode. But those two do have a lot of traction and a lot of GitHub stars. My preferred approach is Axum, which is the one I recommended to you on Twitter. And the reason I picked Axum is just because it's from the team that built Tokyo. And if you're not familiar with Tokyo, it is the asynchronous runtime for the Rust project. There's pros and cons to all of these. But you know what? Rawkode is probably going to be the one that has the more of the wow factor and less of the headbanging. So maybe we should go that way. It will require us to use documentation because it's not one I use regularly.
From a kind of my perspective, what I've done a lot is, PHP, I'll typically lean towards Laravel. If I'm going for something, that's maybe I just want more auto-generated stuff, I'll go for API platform. If I'm not going to use PHP, then I'll use Go, and I'll probably use something like, I used to use Gorilla Mux, but then that disappeared and now it's come back. So at the moment I'm using Chi. So, something like Rawkode sounds like the right thing.
Yeah, I mean, if you've got a Laravel background, Rawkode is going to resonate much more with you than, Axum is much more of a building blocks. You do get a complete web thing for you, but the middlewares and the way that they work require a lot of boilerplate and configuration. Rawkode is just there's the thing, let's do it. So let's go for that.
Yeah. It looks like it just, it's done the hard work for me, right?
Yeah, like I said, batteries included. You don't really need to think or worry about anything. It's just everything you need is going to exist, hopefully.
So how do I start a new Rust project? I've got my terminal. I am good to go.
Yeah, just run cargo new.
Cargo new. Do I need to pass it any arguments?
Nope.
Oh, need to add a path.
Oh, okay, dot, sorry. Or, that. All right, so if you cd into that, you're going to have a cargo.toml, a source directory. You're already into it.
There we go. Welcome to the light mode.
Hey, I used to be dark mode loyal for everything. But, since Mac released like the auto thing, I now do daylight during the day and nighttime at night, and I'm quite happy. So I'm not offended by it.
I used to do that, but it's got to be light mode all the time for me. Otherwise, my eyes just, that gets blurry if I don't look at it properly because of a dark mode. Light mode, it doesn't do that to me.
All right, well, pick what's best for you, right? That's true for everyone.
Exactly.
So if you click on the install or the quick start, whatever you want, it's telling you to do cargo new, which we've already done. The next thing you want to do is add that Rawkode dependency to our cargo.toml. Are you familiar with toml?
Yes.
Right. Okay.
I used it a little bit when I played with R, so relatively familiar.
Yeah, it's just another markup language, much like Markdown, YAML, JSON, etc. A bit different from the rest because it has square brackets everywhere. Other than that, we're good.
Works for me. So we've added the dependency.
Yeah, run cargo build. Just let's get into the toolchain straight away, and then we'll come back to the documentation.
Yeah.
So cargo, like Composer, doesn't really separate dependency pooling and building. It's just one command. So when we do a cargo build, it'll fetch all of the crates, all it's source driven, so it has to build everything, which means it is quite slow. This is a common problem with Rust, but it is getting better. Incremental builds are getting there, which is nice. But this first build will be a little bit longer, and then it should be a lot easier afterwards.
Right, so that's still downloading some crates. So let's have a look at this. So the project layout, you have a source folder with a main.rs. That's kind of like the default from what I've seen. And each Rust project needs to have a main function.
Yeah, nice and simple, right?
Yep. That is what gets me every time. Like, I look at Rust code, it's like, why does it need an exclamation mark?
So let's dive into that a little bit. The exclamation mark means that you are not calling a function. It means that you are calling a macro. So in this case, the Rust standard library provides the print line macro, which actually does all of the underlying boilerplate to write to the standard out device for you. You could do it without the macro. There's a lot more code, but the macros make things easier. And to be honest, especially as we explore Rocket, we're going to be using macros for everything. These are a way for us to not have to worry about boilerplate. It's all handled at the build step of our program, which is nice.
That's definitely nice. So there's an interesting question in the chat is, one question I have for experienced Go and Rust devs is, what are you building day to day with a language? Obviously default to how I can make something for the web. So like from someone who uses Rust a lot, what's your day to day like if you're going to be writing code? What are you typically building?
Rust, like I said earlier, transcended what it was originally for, and I probably now default to Rust for pretty much everything, but I'm not saying everyone should do that. For me, if I was writing a backend service, a backend API, I would go Rust. If I was building a CLI, I would be torn between Go and Rust, because Go has some pretty sweet libraries for building command line stuff, especially from the Charm repository, if you're familiar with Charm.
Yeah.
They make TUIs.
They've got fantastic libraries.
Yeah, it's hard to avoid that. It's hard. Rust has Ratatouille, which allows you to do really nice TUI-based interfaces, but Charm is so nice. So I would be a bit of a coin flip there. And for UI stuff, Rust and Go both have really good desktop libraries now. Tauri is fantastic on the Rust side, and you're already exploring one in Go right now, right?
Yeah, I'm playing with two different ones at the moment. I think I'm going to be sticking with Wales though, which is it's Go and Vue basically. You can use like React, Vue, JavaScript, or Svelte just to build that UI layer. It's nice, but it's like at the same time, I'm like, I don't want to use JavaScript for anything. Like the last 8 years of my life, I've tried to write as little JavaScript as possible.
I've went the opposite way, man. I'm so all in on TypeScript these days. When as soon as I have to write anything that hits a browser, I really like TypeScript. But I think you picked Wales because it just sounds like Wales, right? Like you're just happy to sit and say Wales all day.
Kind of, yeah. I was like,
Wales and Wales.
Here I
come. So pull up your browser for a second. I'll show you what I spend most of my time in Rusty Land working on. If you search for GitHub Comtrya, COMTRYA. It's a Stargate reference for anyone who's familiar with SG1.
I'm more of a Star Trek and Battlestar. I do like Stargate though.
Yeah. So if you just click on that first repository, it's a .file manager for localhost specifically. I wipe my machines, my Windows machine, my Linux machine, and my Mac every 30 days because I'm crazy. And I run one Contraya command and it gets everything up and running for me right away in under 30 minutes. So it's a pretty sweet project. It's written in Rust. It's what I started writing Rust 2018, 2019, and I've been doing it ever since.
As soon as I saw that, I remembered the reference.
Contraya.
Oh, I was watching Battlestar last night, but I've just finished. So I finished Star Trek Enterprise, watched some Battlestar. I'm going to have to go back to Stargate.
Yeah, I have a lot of Stargate stuff in this office. I'm not going to point it all out, but there is a Stargate there.
My guilty pleasure is the Star Trek.
Ah, nice.
My USS Defiant plaque.
Very cool. Ben followed up in the chat and just saying, I want to make sure I'm not trying to fit the language into a use case it's not for, essentially.
Yeah.
Again, these days, now that Rust is so mature, it does really fit almost anywhere in the stack. So you wouldn't be shoehorning it in. We're now in a position with Rust development where it doesn't matter what you want it to do. You don't really need to build anything yourself anymore. And this was always a really big argument for PHP and Ruby, is that there was a composer package for everything and for Node.js, right? I mean, name any project off the top of your head and let's go to crates.io and see if we can get support, because I guarantee it's probably there.
Yeah.
So again, Ben, throw something in the chat. What databases are you working with? What queues are you working with? what do you want to integrate with, and we'll see if there's a Rust package for it. But I'm silently confident. And this sun is blinding me. I'm going to close my blinds.
Sun in Scotland? Are you sure you're in Glasgow?
It's the 3 days a year we get it. The winter sun's always the worst.
We've managed to catch David on the only day in the year that there's sun in Scotland.
Yeah, and also the day where last week, because it was a new year, I decided to redo all my office. And I don't have any lighting set up, which is why I'm also sat in darkness. All right, Ben says SQS and AWS. AWS are pretty all in on Rust themselves these days, so this is not going to be a challenge. There we go.
Straight away.
Over 1 million downloads for the first one right away, so that's pretty sweet.
I'd say that was definitely support. Definitely support. Like, I mean, I'm assuming there's like even a GitHub SDK.
It's called Octocrab, or at least the organization I think it's called. If you search for Octocrab instead of GitHub, I think is the one. There we go. Nice.
I do like the website. That is really, like, if you compare this to packages, this is similar in the layout, but this just is a lot cleaner.
Yeah, you get the README from the repository off the bat. You get docs.rs for all the documentation. I mean, this is one of the downfalls of the Rust community ecosystem. Click on that documentation link. Now, it's great that Rust has primitives to take doc block comments from the code and generate this wonderful documentation for us. But a lot of Rust developers just stop there. So what you get is a very machine-centric code browsing documentation rather than like a usage-based. This is something that Laravel is exceptional at, right? If you want to know how 100%. To do something, you could just say, I want to do the thing, and it walks you through it. We're not quite there yet with Rust, so you do need to kind of speak APIs, understand code structures, implementations and macros and all of this stuff. But those are things that can be easily improved as long as you're familiar with the language. So
it's a mature ecosystem. Like you think of Rust and you think, oh, that's that new language that people are trying to get into the Linux kernel. And it's like, no, it's already there. It's been around for years and it's a lot more stable than you think. Like, it blows my mind how stable it is.
I mean, people are writing complete operating systems in Rust now, which blows my mind.
I actually have seen some of that.
Yeah.
So I'm going to grab this main RS.
Yeah, focus, Steve. We've got a mission to do here. Stop talking about Rust.
I want to build an API. So what we've got is macro use, external create rocket. We want to do a get request / which is our index root. And we're going to be returning a static string of hello world.
Mm-hmm.
Rocket is going to launch. It's not going to return anything, or we're ignoring the return.
Yep.
Then we want to build mount on the first / these roots. So I'm assuming I can kind of stack these up if I've got a few.
Yeah, well,
Am I reading, for someone who doesn't really know Rust, am I reading that correctly?
Yeah, so the first thing we're doing is saying we want to pull in the macros from the Rocket crate. Nice and simple. We're then using those macros to augment our Rocket function with launch, which just means configure this as a main function. And we can actually expand these macros. We won't do that just now, but you could visualize, you can actually see what code is generated for you. And then every time you want to add a new endpoint, we can just add a function with another macro and then add it to our roots. Nice and simple. There's macros everywhere here, right? And we've got inline code macros, as we can see from the exclamation mark, and we have derivative or derived macros, which we can see by the # hash symbol, whatever you want to call that. What I'm going to suggest to you right now is we don't have a lot of information from VS Code about what is happening in this entire program.
Yeah.
So let's go to extensions and install Rust Analyzer. Yep, that's
Here we go.
And your code is going to come alive.
Welcome to the download time you get with Welsh Internet.
Oh, we're okay. That was fast.
Probably going to have to reopen that, aren't I?
Yeah, you may. I don't know. Oh no, it's doing a check at the bottom. You can see the cargo is doing some stuff.
There we go.
I expected more. Hover over the mount function and see if we get any hints from it. Okay, we are getting some. Okay, we're just not getting the inline stuff, but that's fine. I'm not worried about
that. Might be a config thing on my end. I did create quite a minimal setup for this to try and remove some of it.
Yeah, so open your. I'm not going to spend any time on this, and I don't know what the exact setting is, but let's open your VS Code user settings or workspace settings, wherever you prefer, and then search for Rust. And click on Analyzer, and then if there should be like an inline thing. If you just scroll down a bit, maybe we'll see it. Some people love it, some people hate it. I am now addicted to it. So I want to show it. Well, maybe I could just pull up my own VS Code and check very quickly as well.
References enable.
I'm just checking. I think it's called virtual text, actually. It's called, yeah, inlay hints is the feature.
Inlay hints.
Always. Let's go for it. All right, now go back to your code. No. Never mind.
It said no.
Maybe I'll just show you it on my side. Maybe that's a good plan. Let's see. I've opened a project. We'll give that a wee second and I'll share my screen. The inlay hints are pretty cool, but we don't need to worry about it for today's session. Hey, look, you got an endpoint. Job done. I'll see you later.
Yeah. Call it a day, right?
All right, let's share.
This is where you've got to restart your browser because you've not shared on this one for 6 weeks.
It is kind of yelling at me, but let me see if I can trick it because I'm getting quite good at tricking my computer.
So this is actually quite nice. Like, I'm getting quite a lot of information, which I wouldn't usually get. Like, if I compare this to like PHP or Go, or even Node when I'm writing like a quick API, just even the amount of debug information while I'm building is super, super helpful.
Yeah. Right. Back in 4 seconds.
You're stuck with me trying to write Rust. Let's change it. Let's see if he notices. Hello, PHP. Oh, he's coming back.
Yeah. I couldn't trick it, so we're doing it. Hey, where's my video?
I don't know. Your face has disappeared.
Don't want to see my face anyway. It's fine.
Yeah, tell you what, let's focus in on the code, seeing as we're writing code and your video is not working. So I made a slight change to the Rust code to make it a little bit better. I want to know your thoughts.
Where's the code? Oh.
Well, it's the output.
Yeah, I'm not sure about that one.
So where do I go from here?
Well, why don't you pop my screen on and I'll show you the inlay hints.
There it
Quite
is.
interesting. So let's make this a little bit bigger. Now, this is obviously, there's quite a lot going on in this project, so I'm going to try and find something nice and simple. But yeah, let's just come into this function and say that we want to do let ABC equals DAF. What Rust Analyzer does is now throw in this fake bit of code, which tells me the type of ABC, which is a @string. So the inlay hints work for complex types too. You can see here we have an update informer, which is a generic function, which has a whole bunch of stuff on it. And I now just cannot code without all of this information being bombarded at my face, which for the first month, I hated it. It was overwhelming. But eventually you just kind of start to get used to it and it becomes really, it's just nice being able to see what everything is, because Rust has a lot of type inference rather than things having to be statically typed. Like you can do ABC, let's call this a string, and do string from and say hi. You can do it that way, but save yourself some typing, let the compiler do it, and you still get the value at the other side. So like these things are quite nice when you get them all turned on and tweaked for your IDE. It works in JetBrains, it works in VS Code, it works in NeoVim. I'm sure it works in Emacs. I haven't tested it, but yeah, all these things are pretty sweet.
I'm pretty sure that people who use Emacs are still writing Lua or COBOL, aren't
they? Potentially, yeah. You never know. Maybe some Prolog as well. But yeah, this Rust Analyzer is such an amazing project. It gives you all of this stuff. Now, there's one thing I showed there, which is the common issue with people adopting Rust, is there's like 3 different types of string, and you have to know when to use the right one and the wrong one, and so forth.
Yeah, you can have a mutable or immutable string depending on the type that you kind of create it as, right?
Well, it's not just that, right? It's even more complex. So you've got hello PHP. You've got let def. Sorry for my terrible naming of variables here. We've got hello from, let's say, Ruby. And then we've got one last one, which is GHI, which is an OS string, where we can say from. Yeah. 3 different types of string, although I don't remember how to actually create an OS string, but let's ignore that for now. So this one is a pretty much hard-coded string that the compiler understands. It doesn't change at runtime, and is very good on the memory side of things. Pretty much a static string. Here, what we have is a runtime string, which is a string that can come from dynamic variables. That could be responses from APIs. It could be user input, anything that you have to mutate, work with, transform in some fashion. And then if you're taking input from a terminal application, then that's probably going to be some sort of OS string, because it's going to be different across Linux, Windows, BSD, and so forth, different representations. So those have to be handled. So depending on what you're doing, you have to know which type of string. And of course, like you said, if I want to say, like, there's no pen here, but if I wanted to concat, that wouldn't work. We'd have to then come back and say, well, actually, we want to make this a string that we can mutate. So yeah, there's a lot to learn with Rust.
Yeah. and I think that's one of the things that kind of really, I guess, put me off at first with Rust, was just, I was coming from PHP. I'd had a little bit of experience with compiled languages, and I was deciding between Go and Rust. And Go just looked scary. Like, at the time, I was like, okay, so if I'm going to go for a language like Go or Rust, I want to be able to use generics. So I want to look at it with generics. And it just looked like someone had thrown Perl and Python together. And I started having flashbacks. So I was like, no, I'm going to go with Go.
Yeah. The people that created Go wanted it to be an easy language to pick up. The people that created Rust want you to suffer. That's all I could say.
So let's look at this API. Like, let's say we want to create another route and we want to be able to get that query parameter so we can do, hello, whatever. So we're going to have something similar. Let's have a look at requests, perhaps. Dynamic paths.
Yep.
Literally that. It's almost like the gold standard of what should I add. So then we could just say hello.
And there, that's it.
And I'm assuming I need to do cargo run again.
Yes. So there's no hot reloading with Rust server-side stuff. So
yeah. So I can do my get to there. Is that going to work? Yeah. So yeah, arguments I can start to pass through dynamic content.
So try it without the Steve.
Oh, 404 straight away.
Yep. Nice.
So it's just handling the use cases, converting that to a string. Cool. It works.
Hopefully that does what you expected it to do. So.
Yeah, exactly. And what I can do as well is that was something else I was building. We're going 8,000. Hello. Ooh. Socket said no.
I'm not sure why.
There we go. Might be something that I've done. It's usually the case. So that is benchmarking the default cargo run, and we'll start seeing loads going on. Yeah, probably should have lowered that number maybe.
What is it, 1 million? Yeah.
1 million with 50 concurrent connections. So it takes a little bit of time.
Well, you're doing 50 concurrent connections. You could probably get that 500. It'd be just as quick. Depending on how many cores you have on your machine. So.
I'm on a Mac Studio, so it should, in theory, be reasonable.
Yeah. Let's change that concurrency value after this. I reckon you could push that much higher.
Oof, too many.
Yeah, but let's go for too many open files. That could be tweaked with your limit, but let's not get into that just now. What?
Get to 100. There's another way. I always see people using a command called WRK, but I never knew what it was.
It's not a command I'm familiar with.
Oh, no, it's not what I wanted. Stop. Oh, looks like I'm installing it.
Command I normally use is called drill. It's written in Rust.
So, connections, durations, threads, similar. Very similar. I just use Apache Benchmark because it works. But I'm getting ahead of myself.
Right, so let's do one more thing, right? Just because I'm very curious. Go back to your terminal. I mean, that's almost... Oh, okay. Run ulimit space -n space... space 5,000, and then set the concurrency to be 5,000.
Another thing built-in Rust that I am using. Warp. Ooh.
Okay, try 4,000. Maybe you just need to give it a... Or maybe the U-limit didn't take. It should have. Oh.
You could always do it manually. Concurrent, we'll do 4,000. We'll go. Oh, I can't type today. I had almost a day off yesterday. I'm just going to go to that one.
What happens if you run U-limit on its own? It should give you a value. Huh. All right, let's not waste any more time on that. That's annoying. But...
Yeah, that's just silly Mac. So, what other things could be useful to understand with Rust and building an API? Like, we're going to use Rawkode, so realistically, we can really dive into the docs to understand it. Go run is working.
So right now you're doing something very simple with path-based routing. But let's assume we were going to be working, a real API is likely you're going to have to accept some sort of post request, which takes some sort of JSON object, which has structure that we want to deserialize. I think that would be a pretty good next step.
Definitely.
So let's add a post endpoint called new, right? Where we want to instantiate or create something on our backend, and that's going to have a type that we need to work with.
We're going to call it new. And that's going to accept no arguments because it's a post request. Keyboard, there we go. For now, an underscore maybe. So, doing post request
just means anything, but we can just let's just do it. Well, let's remove the return type until we need it, or make it a string because we're going to have to return a JSON payload back to the user, the client, right?
So post requests. Let's go have a look.
Well, let's define our type first.
Okay.
Well, you found one, so you can copy and paste it if you want. But that struct there is what we want to do, and the library that we're going to use to do the serialization is called Serdi in Rust. So if you just copy those first 8 lines.
So we're going to want that and that.
Yep. And then we'll update our posting afterwards. So the first thing we need to do is pull in the use statement, which we've got, and then define our type. So what do we want to create a new one of? They've got task, but we can make it anything, or you can keep it task. It's up to you.
We'll keep task. It's to do app API at the end of the day, then, isn't it?
Mm-hmm. And we do have some scary stuff there already. We have a lifetime called R.
Yeah,
so this is how long that will stay in memory. The description string will stay in memory for the lifetime of R, and R is bound to the struct task. So, yeah, we can skip over it, or we can talk about that more. It's up to you.
Is there like a kind of idiot's guide to what that means? Because I mean, coming from a language that doesn't have memory management.
So this is one of the main differentiators between Rust and pretty much every other language. Let's focus on Go, though, because I know that you have experience there.
Yeah.
Go is a garbage collected language, and it does this through reference counting. So whenever you have a variable in memory, it won't remove it until all the references are gone, and that happens with a stop the world garbage collector, which means that every interval of time, the Go compiler, the runtime, will say, not the compiler, the runtime, will say, let's clean up our memory, and all execution stops. It might only be for nanoseconds, milliseconds, or whatever, depending on the complexity of your memory management in your stack. But it says, okay, there's no more references. Let's clear this. Let's clear this. Let's clear this. And if you profile a Go application, you can see where the garbage collection kicks off based on your memory utilization. Rust does not have any garbage collection whatsoever. What actually happens is every time you allocate something onto your stack or heap, it puts it into memory. You can do reference counting with arc objects. Maybe we'll get into that later. That depends how deep we go. But what happens is whenever you have a piece of memory and you change function, your stack changes, whatever, it's all wiped out unless it is persisted or needed for longer than that lifetime. And that's where lifetimes become so important. So it can be that you give something a static lifetime, like those strings we saw, which live for the entire runtime of the application. But for a web-based thing, your lifetime is pretty much always going to be the request. Request comes in, things live in memory. When the request is finished, delete everything. That's how memory, the memory consumption of Rust programs is usually so small because it only ever has what it needs without having to do any garbage collection. Does that help?
Yeah. That makes sense.
Okay. Yeah, so that's R lifetime. They're just using R to mean request, and nice and simple.
Perfect. So what I'm going to do, I'm going to clean this up quickly, and we're going to add that the way we need it to. So what we want to do is have a new post request, which will take a task. So post to-dos, the data is, I'm assuming that's just doing some magic under the hood, right?
Rust is all magic. Yeah, batteries included. So it's just, it knows to go grab that type and deserialize for you. Plus we also have that in the thing. So we've got the type within the signature of the function, and we expect the task as data task, some sort of JSON name.
Awesome. So that, like on in PHP, for example, we've got doc blocks. This is just kind of telling Rawkode that it's going to accept a task, and then we're going to work with it within the language itself down here, right?
Yeah.
Is that similar?
I mean, I'm not 100% sure on the data annotation on the macro because I don't use Rawkode that much. But let's just explore and see what happens. Excuse me. Now,
very much.
Yeah. Let's just do it. Let's break it and see what happens. So let's just return the task back to the client.
Okay. So, do you need to write return?
So this is where Rust has both expressions and statements. So you can explicitly do return task semicolon, or you could just do task on its own, which would be an expression. No semicolon.
So
then for that, we will need a return type on our new function.
And that would be...
Let's make it a string. I'm sure Rawkode has response types we could compose manually, but it also does magic. So if we say we're going to return a string, it will return a string. And with that, we could take a look at our task object, and maybe we just return one of the properties rather than the full task. Yeah.
I'm not seeing any errors.
Yeah, I'm surprised by that.
So am I. Could not find JSON insert a.
So we're going to have, oh, yes, we have to add the, no, we have Rawkode Serde. Yeah. Or maybe it's not built with that feature. Okay, so here's another cool thing with Rust. When you consume a library, libraries have features, meaning you don't have to buy into the entire Rawkode ecosystem. You could build with a minimal set of features that we need. So it may be that we have to enable the Serde feature on the Rawkode dependency. So let's go back to cargo. Now, we can change this line ourselves by wrapping it in curly braces and then name version equals 050. And we can also do features equals, and it's a list, and add Serde to the list.
Like that?
The other way to the other way to have done this would be just to run cargo add Saturday -- features equals sorry, cargo add, but we don't need to do the command line version. Let's try a cargo build and see if it's happy. Okay, so I'm just looking, and we do have to manually add the Saturday dependency too, and the Rawkode documentation.
So cargo.
Just that to chat.
Something like that.
I don't think you've updated to cargo.toml.
So what do I need to do to this?
I sent it in private chat.
So you did. Oh, I just need to add that as another one.
Yeah, I had to check the Rust documentation. I wasn't sure because they're actually wrapping the Saturday create with their own definitions. So I wasn't sure how that was pulled through. But it looks like you just add the Saturday dependency yourself. So.
And
I'm just checking to see if there is a feature that we need to enable.
ooh. Could not find JSON in Saturday. So now I need something else. Is there anything in here?
Yeah, so you have to add the feature JSON to Rawkode. Not to Saturday, to Rawkode. Yeah.
Do I then have to list all of the features that I want, or just...
No, we just need JSON. We should be okay.
There we go. It is building.
Okay, so it just wants us to handle some... I can't see the error message completely. But if we go down to...
saying that this needs to be that.
Well, I mean, we can convert it, but that's fine. That should be okay.
That worked.
Did you add the brackets and the star to task?
Nope. That looks like it is.
That's the inlay hints, right?
Inlay hints are finally showing. It just wasn't complex enough yet.
Perhaps. All right, let's try cargo run.
So if we were to do that, that is what it wants to see. And this wants to be...
Well, yeah, so all string slices have a static lifetime, but them you don't have to do them manually.
Cool.
See what I mean about Rust? Lifetime to master.
Yeah.
There is a lot.
So we've got in debug, we've got our Rust API in there. So what we want to do now is just target debug.
We can't see the terminal. You need to move our faces.
Here we go. Let's put our faces over here.
Yeah, that's better.
So in target, in debug, I have my REST API and I can run it. It is launched. If I come back to here, I can do a get. Post to, you know what? I am going to use HTTP. It's going to be so much easier than using the command line, right?
Yep.
So we want to do a post request to 127.0.0.1 port 8000 tasks, I believe it was, to do. And if I just send that, it's going to complain.
Yep.
400 bad request, perfect. So then if I say I want to accept application JSON, it's got good error code straight out the box. The content I want to send over is application JSON. So let's go add a body of learn Rust. Unprocessable. Perfect. So it's doing validation out the box for us. And then if I play some type problems, it's saying no. Learn Rust. We got it.
All right. So let's default the complete. We don't need to provide that, right, to create a new to-do. So let's remove it from the JSON payload, and we'll get the error that says our type isn't complete, essentially.
Yeah.
And then let's go back to our Rust code and make that work.
Let me put that over here. It'll make more sense.
Okay. So if we go to our struct, what we have here is a task definition with two properties that are required. So let's make our complete an option bool. So change bool to be option with a capital O. And it's a generic that takes a bool. And now we have an optional type.
Nice. And that's obviously dead code because it's...
We just never use it. It's just telling us that we have this type. You could obviously change the new response to include the complete if we wanted, but fine.
Now I don't have to pass it.
Yep. Neat, right?
A lot easier than you'd think, right? You look at like Rust and it's just so crazy to look at. If you're not used to, you know, memory lifetimes, structs, generics, like all of that. I mean, does it matter where this is? Because to me, that should be there.
Okay, so let's do one more thing. Let's refactor this, right? So yes, that does matter where that is because we are adding those macros explicitly to the struct, not to the entire file.
Yeah.
But it may be that we don't want to keep adding stuff to main.rs, which means we now have to understand the Rust module system, and let's extract our task to its own file.
Okay.
So let's create a task.rs. Let's copy and paste the code, or cut and paste, yeah.
Want that in here.
Yep, perfect.
Then
let's
in here,
delete.
delete all of that.
And let's build and get an error message, because error messages are good, right?
Build or run?
Well, run just does a build anyway, so.
Cool.
Okay, so first problem is we need our Sergi JSON scope in both files. So let's copy that into the main.rs2, because both of them are used in... Well, actually, we don't use JSON here, but it doesn't matter. Let's just copy the whole thing and we could tidy that up later if we wish. Okay, and then let's do a run again and get the next error message.
JSON in here.
Yeah, we're actually not using it here, so you can delete that if you want. And then it's telling you don't need the braces for a single import. Yep. It's telling you here you don't use deserialize. Yep, so you can just kind of tidy this up. All right, and then let's do a run and we'll get some more error messages. Now we don't have access to our task type, right? So it's like, hey, what the hell's a task? So we've moved it into its own module. With Go, you do this through capitalizing the names within the same package. But actually what we need to do now is say that we have another module called task. This won't work yet. See, no autocomplete. Nice try, though. So at the very top of our file, what you probably want to do is mod space task semicolon, which means pull in a local module. I'm just going to autocomplete it. Now we've consumed a module, but we're not using our task definition. So now we can say that we want to use task. Now, one more problem to fix. This is a private structure. So go back to task and make it public. Just add pub to the start. That's it. Now, the module system is quite intricate in Rust. And when you make things public, you can make them public to everyone, public to the crate, and so forth. So we could tweak that and say that we want it public within our application, but we don't want to expose it to other people. There's loads of things we can do here. Yeah. We can export everything. We can export single things. We can export aliases. There's a whole bunch of stuff we can do here. So if we save all our files, what is still saying? Go back to task.
Description is private.
Yeah, so now we're trying to use a single field. So let's make it public right now, and then we're going to refactor it again. I don't know how long you want this to go, by the way. I mean, if you want to sit here all day, I'm good. But let's make it public.
We've got another 20 minutes.
All right, okay. So let's make it public right now, and then we're going to change it so that it's cleaner, right? Because making properties of a structure public is not usually the best approach. All right.
So it is up and running again, and it is working.
All right. So there's two more things I want to do. Let's go to task RS and remove the pub from description.
Yep.
Let's create a function on our task that exposes the description for us. So we want to do impl task, which is implementation for the task structure. This allows us to bind functions to that type. And then curly braces. And then inside of the curly braces, we want to add a new function. So pub function get description, whatever you want to call it. It's up to you. Rust Analyzer will tell you to use snake case.
Okay, so you prefer snake case in Rust?
I don't prefer it. The language tells me. Anyway, that's going to return a string.
String.
You need the dash greater than symbol.
Bloody keyboard.
Is that a Moonlander by any chance?
Yep. How did you get?
Because I've went through the same pain. That's why. Where we can return. So we need to pass an argument So it's at self on depth description. So we want to use our at ampersand, sorry, self.
Ah, no.
And it's and then we can return self.description. All right. Because the task has a just add the lifetime to our task implementation.
That. Ooh. What did I do? No.
R.
There we go.
Sorry to interrupt. Oldham died.
Last night.
No, this morning.
Everyone okay?
Yeah. I just wanted to quickly tell you, I didn't do something that could wait, but death waits for no one.
Death waits for no one. So, you have undeclared lifetime name R.
Oh no, move it to after the IMPL. No, after the IMPL.
Oh, my bad. My bad.
All right, I'm having to Google this one myself because hopefully we can get there. Implicit allowed lifetime is not allowed here. Expected an anonymous lifetime. Okay, remove the R and do anonymous, which is underscores. That was my bad.
And put it after the task.
Oh, fuck off, Rust. Sometimes the inline errors. Yeah, okay. Sometimes the inline errors are easier to just run cargo build because you get a lot more context, but we got there, so
yeah,
let's not worry about it. Okay, so now we're still using the private field on our main, so let's use the function and remove the. Just do task.description. We don't need any of the. No, we don't need that. We're just removing all the stuff, the brackets, the star. Get rid of all that. Just task.getDescription. There's no point in us referencing and dereferencing. So just and then add the function. Call the function at the end. Phew. Why is it complaining? Oh, we're getting into the guts of Rust now.
Oh, we are. I had to make it hard on myself, didn't I?
So let's go to task.rs and we're going to use the Rust get out of jail free card.
Okay.
And we're going to do description.clone. Does that help?
Let's see what the compiler has to say about that.
Oh, it's complaining the task is borrowed.
Yes.
Right. So this is just the way that Rawkode is passing in our object. So I'm not sure if we can tweak this, but let's try. Let's do task. We haven't implemented clone on our type, but we could fix that. Okay, let's do task.clone.description. And I'll try and explain all of this afterwards. Let's try and get it working first, though. All right, so now it's going to tell us that we haven't implemented the necessary things on our type. Hover over the error message. Yep, so it's telling us that we have traits that have to be implemented. So we can go up to our type definition in task.rs and we can start to layer these on. So derive to serialize and then clone. Yep. And then see what error messages we're getting in main.rs.
Cannot return value referencing temporary value returns a value referencing data owned by the current function. This is a bit that really scared me with Rust. It's just like, oh wow, okay, I'm going back to Go.
Yeah, the challenge here is that we're doing the clone, we're not assigning it. There's no machine understandable lifetime, and then we're returning something that is a reference to a temporary cloned value without a lifetime.
I'm doing Rust wrong, is what we're saying, right?
No, what we have to do is we have to have something that we own, right? So we can't do this in a single line anymore.
Okay.
So let's do let task equals. In fact, let's just do let description equals and then the rest of that line so that we have a string that is ours. And then task, yeah, right? So now that string is ours, and let's return description. And the error message is, oh, we just need a semicolon after get description. Hopefully.
Cannot return value referencing temporary value, returns of value referencing data owned by the current. Okay, I got an idea. Let's see if Steve can figure it out.
Can't call it new. I don't think.
Gonna
Or maybe
complain
we're
about something.
Yeah, you have to use our function.
New local variable, new. Oh, come on. I feel like I'm going in circles.
Yeah, that happens a lot with Rust. And like I said, I've been doing this for years and I still hit this stuff all the time.
I hate it when it says that, when it says no quick fixes available. That's like the thing you don't want to see. Okay, so that bit is fine.
I think what we might have to do is, I was trying to find an example of this in the Rawkode docs, but we may just have to add a lifetime to our new function. So I'm just seeing if I can search. Oh, I don't actually see anything about lifetimes. So you'll need to give it a name. It can't be anonymous here because it's a function. So let's call it R, and then assign that assign a lifetime to the task and the thing.
This, the new task. Okay, so does it matter? Oh, wrong thing.
Yeah, so we wouldn't be able to add it there. What we'd have. But let's just see and task JSON task, and we've got the lifetime underscore. Let's change that to R2.
This bit here.
But above one line up. So let's make that the same lifetime as our function.
Yeah.
And hit save. Our end hasn't updated. All right, okay. Let's try returning task.getDescription now without any of the other stuff.
Without that.
Yeah. Oh, I hate you, Rust, so much. So returns a value referencing data owned by the current function. Yes. Why is that bad? We got the lifetime on our function. Yeah, we could try cloning again. Clones usually get a jail-free card, but for some reason it's just not happy. Let's see. Help me documentation.
And this is why I don't like Rust. because it's just
No.
scary as hell. Like, if
I mean,
this
this
is your go, it'd be easy.
true, but with Rust, we get a program that never crashes. Granted, right now we don't have a program that works. However, this is because I'm not that familiar with Rawkode. What I don't understand is the data flow from our function back to the Rawkode request stack for the response. There will be a way to propagate the lifetime from the request into this function and assign it to our task. I'm just not that familiar with this right now. So what we can do, because I do want to show one more thing and I want us to finish on time, is let's just remove this function call and make the property public again. And we'll do another session where we dive into this.
So we'll drop the implement.
But you can leave that there, it's fine. It's just dead code, right? But let's make description public.
Public description.
And then let's just throw it back, right? Okay. So I at least showed you how to implement functions on the type and use them. We did run into an issue with the lifetime. Again, let's not focus on that. Now, assuming we've got the most recent version of Rust Analyzer, I just want to show you what is actually happening with all these macros.
Okay.
So go to launch. In fact, it depends. Do you want to take a look at the main function, or do you want to take a look at what's actually happening on the type or the endpoints? Pick any of the macros.
What's happening on the endpoints?
Okay, so click on post, and then do Command-Shift-P and type expand. And find the Rust Analyzer one, so expand macro recursively. And this is all of the code that is being generated for you with that macro.
Wow.
So our endpoint is pretty simple, but then there's all the Rawkode magic that goes into it. So
Jesus.
If you ever want to understand what your macros are doing, Rust Analyzer, this is really new in Rust Analyzer, like a week or 2 weeks old or something. But you can now actually see what the macro is doing to your code.
I don't want to know what it's doing.
Why not?
That is just something else.
It's nice to see what it's doing, because sometimes you add these macros and, like, in fact, let's take a look at tasks.rs. Let's expand the Saturday stuff, right? Because that's just an implementation on top of your type, which is quite nice to see too. So task.rs, and let's expand the derive macro.
Not available.
Try the Saturday one.
I'm hitting the wrong key, aren't I? I'm just zooming in. There we go. Oh no, it's still not available.
Well, screw it. It was a terrible idea. Didn't like it. Yeah, I guess I could show you on this side. The Saturday deserialize and clone stuff is just an implementation for our trait on top of our struct. So it's like, implement clone for task, and then it adds functions for clone, which does all the memory management for you. And it does implement deserialize for task, where it has a deserialize function and so forth.
Yeah.
So this is how we layer behaviors onto types across the entire language and application in a very neat way with the traits and implementation method. It's very, very cool.
Yeah, no, I definitely like that. It does a lot of kind of clever stuff under the hood for you, so you don't have to. Like, I'm used to traits and stuff in PHP, but that's almost like the poor man's trait compared to what this is doing.
Well, yeah, traits in PHP are compile time or runtime copy paste, right? It doesn't really have any awareness of what's happening. You don't get the type safety guarantees that we're getting with Rust. And with generics and stuff like that, it's super powerful. So.
Yeah, massive. I mean, I'm seeing the power of Rust just by doing something really simple like this, just how much it does for you and how much it forces you to write things properly. Just great.
Yeah, very cool. All right, that was awesome. I enjoyed that.
Yeah, there's definitely definitely something new. I definitely have to keep trying this. So one thing I noticed before you do go, there's different types of build, right? If I just run cargo build, it's going to do it, but it's going to complain about stuff.
And just
Ignoring that.
warnings, yeah.
But there's another way to build, right? You can do, because that's the unoptimized and debug info.
Yeah, you could do -- release, and you would get a production binary. So it has to recompile every dependency, stripping out all of the debug information and symbols.
Yeah.
And it spits out a binary that is substantially smaller than your
And a lot
debug one.
faster, from what I noticed.
Oh, yeah, just because it's really stripped down. It's made to run performant efficiently and fast. So. But I mean, just take a look at the size difference, right? Do an ls-l on target debug and target release. All right, so with 17 meg for debug release, and then under 4.7 meg for the production. So.
Yeah, like when I was testing Rust the other day, you saw on Twitter, like the unoptimized version of Rust was slower than Go, and I was like, I thought Rust was meant to be super fast, and then it's like, oh wait a minute, that says unoptimized. How can I optimize that? So I dug into the docs. I was like, okay, now let's try it, and just like it blew Go out the water with speed.
Yeah.
No, sorry. Can I take your Monzo card?
Yeah.
The girls have lost all of my bank cards.
Yeah, take my card.
Every single one of them.
Children.
Tell me about it. Hey, Mark, in the chat.
Hey. Wow, that was definitely enlightening. Like, just I'm gonna have to sit in a dark room. Luckily, I'm already in one for a little bit, just to get my head around some of this and how it works. I love that approach, that mod task. That's really nice. It's a lot clearer. Like the way that I do it in Go is just to import from like my module, but it doesn't always, it doesn't differentiate between remote module and local module.
You can. So let's do that another way. Let's type mod. Create. : task. So you can say, I mean, it doesn't make a lot of sense here, but you can reference your own create and pull in types that way as well. Oh, no, wait, sorry. The mod is mod task, and then you can use create task rather than task. So you can differentiate between remote and local use statements that way.
No, that's just super useful. Like this, I can see I'm using a local module, and so I'm pulling in the local module and saying I'm going to use it there. Whereas in Go, it's just literally import. It just looks the same as the others. So it's nice to see.
Yeah. Cool.
Great.
Yeah. Anything else you want to know, or is that are we done?
I think you've fucked my brain enough for one day.
Yeah, I'm going to have to go and work out how Rawkode handles that lifetime propagation because I want to know how to handle that clone. But other than that, yeah, I enjoyed it.
Yeah, that was a lot of fun. Thank you for teaching me some Rust. I'm going to have to try and do it some more just to see what I can do. Because I'm not going to let it conquer me. It's not going to beat me. I'm going to be writing Rust all the time now.
Cool. Well,
it looks like I'm going to have to get rid of my gophers, right?
Well, I mean, I've got some low-hanging fruit and easy first issues on Comtria. You're welcome to join and try and help us with that project if you really want to. But check it out and let me know.
Yeah, no, I'm definitely gonna have to check it out because it looks like something that's useful anyway. So thank you
Awesome.
for coming. Thank you for teaching me. Stay awesome and go enjoy the one day of sun you get up in Glasgow.
Awesome. Cheers, man. Have a great day.
Thanks, buddy. Thank you. Catch everyone later.